Today's our second lesson in this unit, and we're going to continue with what we did before. We're still going to be looking at arithmetic sequences, but we're going to look at sort of different terms and harder types of questions today. So we looked at a few of these yesterday where we had to find first terms, things like that. So this question doesn't look much different than what we did before. Basically, the trick is, can we figure out what these three middle numbers are? So the definition that we're going to learn today is what we call an arithmetic mean. So think of it as a mean typically means average. So we're looking at what would be three numbers that are averagely spaced out equally between 28 and 42. So once again, we could guess. We could try a number like 5. So we add 5, we'd have 33, 38, 43. So that's obviously too big. Try something like 3. We'd have 31, 34, 37. That's a little bit too small. So it looks like it's going to be 4. So we'd have 32, 36, and 40. That doesn't work either. So in this case, we're probably going to get some sort of decimal. So we'll leave this one for now. We might come back to it, but we'll figure out what this is. So from our formula that we were looking at before, remember, we can use this formula to solve for anything. We don't have to look for a certain term. We could actually solve it for D, we could solve it for N, whatever the case is. So this first couple of questions we're going to look at are using it to solve for N. So our first example, we have our sequence. You can see we're going up by 21 each time. So let's put that down. We have a difference of 21. We have a term 1 of negative 16. And the question is going to say find N in order to get to our last term of 866. So remember I said yesterday, our T of N, you want to think of it as being the last term or the term you're looking for. So that's it. We can plug everything into our formula. So we have 866 for our last term. Term 1 is negative 16. Our D is 21. And we have N minus 1 is what we're solving for. So let's just FOIL that out and solve. So we did a question kind of like this before. So when you multiply the 21 out, then you want to combine your like terms. We'd have 866 is negative 37 plus 21N. Add 37 to both sides. So that'll give us 866 plus 37 is 903. So we have 903 equals 21N. Divide by 21. And we have N of 43. So that means if we kept going in this sequence, the 43rd number would be 866. Here's another one, same sort of thing. It says Halley's Comet appears every 76 years, was last seen in 1986. Comet Kojima appears every 7 years, was last appeared in 2007. So it's asking, will both comets appear in the year 3043? So it's a little bit different question, but we're still basically trying to figure out the same thing. So the easiest way to do this one is just put these numbers into our formula. So in this case, Halley's Comet has a D of 76. And let's call 1986 as our term 1. So that's when it's going to start. So it's going to repeat every 76 years from that. So let's plug it into the formula to see if T of N is 3043. Or let's see what term that would be. So if we plug all that in, we'd have 3043 equals 1986 plus 76 times N minus 1. So all we want to do now is simplify and solve for N. So we have 3043 is 1986 plus 76 minus 76. Let's put our like terms together. So 1986 minus 76 is 1910 plus 76N. So let's subtract the 1910. So 1133 and divide by 76 and we get 14.9. So the question then is, will it appear in 3043? Well, if we're getting at N of 14.9, that means we have a decimal answer, which is impossible, right? N is first term, second term, third, fourth, fifth, and so on. So it has to be a whole number. So that one's not going to work. Let's just try it. Let's just, for argument's sake, let's see if the comet Kojima will appear in the same thing. So we basically do the exact same thing, except we put in 2007 as our starting number, and we put in 7 as our D. So let's solve this one. So 3043 7n minus 7. So we'd have 3043 equals 2000 plus 7n. Move the 2000 over. So we have 1043 divided by 7 gives us 149. So that one will happen in 3043 because it's a whole number. The Halley's Comet won't because we get a decimal. Okay, so back to where we started at the title page. We're talking about arithmetic mean. So now let's actually figure out what this is. So arithmetic mean, it means that we're looking for the equally spaced numbers in between n terms. So really what we're trying to figure out is the d. Let's solve for the difference. Once we know that, we can then plug it in pretty easily. So let's call 12 our term 1. Let's call 72 our nth term. And in this case, we have 4 terms. And let's just plug it in our formula and solve for d. So we'd have 72 equals 12 plus d times 4 minus 1, which would be 3. So we bring the 12 over, we get 60 equals 3d. 60 divided by 3 is 20. So you can see we can just add 20 each time. So we'd have 32, add 20 again, we get 52, add 20 again, we get 72. So once we figured out our d, we can now solve for those arithmetic means pretty easily. So the same numbers again, except now we've got 6 terms. So we can plug it into the formula. So 12d times 6 minus 1, which would be 5. So we get 60 equals 5d. Divide by 5, we get 12. So in this case, we're going to be adding 12 each time. So we'd have 24, 36, 48, 60, add 12 again, gives us 70. Okay, so anytime you're looking for arithmetic means, that's usually the best way to go, is solve for d, and then once you have that, you can plug in any missing number. Our other thing we're going to look at today that's a little bit complicated is when we get variables involved with the sequence. The same rules apply. The only thing you got to be careful is you're dealing with x's and so on. So if we figure out this pattern, we got x plus 1, 2x plus 1, 3x plus 1. So you can see our next 2 terms would be 4x plus 1, and then 5x plus 1, and so on. So our general term then is term 1, which would be x plus 1. Our difference, you can see we're adding an x each time. And that's it. So you could leave it like that. That would be a good enough formula. Or we could, if we wanted to try to FOIL it out, we could. So let's try that. So we'd have x plus 1. We'd have x times n minus 1 times x. And you could actually see the x's cancel in this case. So we actually just get x times n plus 1. Which makes sense because we're just going x times 1 plus 1, x times 2 plus 1, 3, 4, 5, and so on. Okay, so let's try another one. So here we got term 1 is negative 6x, our difference is negative 5x. It's asking which term will negative 81x be. So we got our t1, we got our d, let's call that one our tn. So we plug it in our formula. So tn is negative 81x, term 1 is negative 6x, our d is negative 5x, and we're going to solve for n minus 1. So in this case, what we're going to do is we're not going to actually FOIL this one out. Let's simplify things first. So let's first add 6x to both sides. So 81 minus 81 plus 6 would be negative 75x. Because we have n minus 1, these are being multiplied, we can actually divide this out first as well. So negative 75 divided by 5 is 15, and you can see the x's cancel, so we just get 15 equals n minus 1. Add 1 to both sides, and we get 16. So that's a little bit of a quicker way to work with the formula. You don't have to FOIL out the times the n minus 1 part. Okay, here's another one. We've got a sequence m, 3/4 m, 2/4, 1/4, and so on. So you can see really what we've got is this would be like 4 over 4, and then 3 over 4, 2 over 4, 1 over 4, and so on. So our term 1, we'll write it as m. Our difference in this case, we're going down by 1/4, just subtracting 1/4 each time. So m minus 1/4 m, minus 1/4 m, and so on. And we're looking for term 7. So our n is 7. So term 7 would be m minus 1/4 m times 7 minus 1, or 6. So 6 times a quarter is 1.5. So 1 minus 1.5 would be 1/2. Or 0.5. So we can write it as 0.5 or a fraction, whichever. So we could continue with this, and it works out pretty good. Just hold on one sec. I think we have, yeah, sorry, it should be negative 0.5. 1 minus 1.5 is negative. Yeah, so we got it. So term 7 would be negative 1/2. Okay, so let's try the next one now. It says if term 6 is negative 12, then what's the value of m? So you can see here again now they're giving us another variable add-on. So they're telling us term 6 is negative 12. So what I would do in this case, the best bet is actually let's solve it for term 6 just like we did the previous questions. We'd have m minus 1/4 m times 6 minus 1 would be 5. So we'd have m minus 5/4. So 1 minus 5/4 would be negative 1/4 m. So now they're telling us this is actually equal to negative 12, so we can make it equal to negative 12 and solve. So if we times by negative 4, we would get an m of 48. We'll finish off this topic by looking at a few word problems, and the word problems aren't any different. You just have to be careful how they're worded, and you want to make sure you label your T1s and your N's and D's and so on. So in this case it says we have a second row has 52, so our term 2 would be 52. Fourth row is 26, so that's our term 4. And they want to know how many is in the bottom row, so we're looking for term 1. Okay, and then they want to know how many rows are there if we just keep on going. So let's start with that. So we're looking for term 1. We know we have 52. Term 3 we don't know. We got 26. So in this case we could use our formula to find D, but because there's only three terms, it's pretty easy. You can see that we're just going down by 13. So if we subtract 13, we'd have 52 minus 13 is 39, and then minus 13 again would be 26. So if we go the other way, we could add 13, we get 65. So term 1 is going to be 65. That'll be our bottom row. And if you couldn't do that, we could go back to our formula again, find D first, and then plug it into the formula. So we'd have a term 1 calculated that way. It makes no difference, whichever way you find easier. So we'll stick with this. We have term 1 is 65. So now it's saying how many rows are there? Well, let's just continue the pattern. If we subtract 13 again, we'd have 13. Subtract 13 again, we'd get 0. So 0 doesn't make sense. That means there's no cans on the top row. So that's it. So we actually only have 1, 2, 3, 4, 5 rows. So that would be our final answer for that one. So sometimes with the word problems, you got to do a little bit of logic, make sure it actually makes sense based on the question. Okay, here's another one. So it says the sum of interior angles in a triangle is 180 degrees. So a 3-sided shape is 180. A quadrilateral, so a 4-sided shape is 360. 5-sided shape is 540. So you can see our pattern basically increases by 180. We just add 180 each time. So in this case we'd have our D is 180. Okay, our term 1 is 180 as well. And the question is saying what would be a 12-sided shape. So we want to figure out what 12 is. But we got to be careful here. We're not starting with term 1, right? So we have basically term 3 is 180, not term 1. So we want to go from term 3 up to term 12 and solve it that way. So we can do that. We can figure that out, or what's probably going to be easier is let's call this term 1 instead of 3, and then that just means if we go from 3 to 12, that'd be the same thing as going from 1 to 9. So that's probably the easier way. Let's go back to term 1 being 180, but now let's solve it for the 9th term instead of the 12th, because we're starting at 3 to 12. So you just got to be careful, or should it be 10? Let's be careful, make sure we're clear on this. So if we go down by 2, it should be a 10th term, not the 9th term. So we should be good. So we can actually solve it for term 12, or sorry, in this case term 10, and term 1 was 180. Our difference was 180, and 10 minus 1 would be 9. So 180 times 9 plus 180 gives us 1800 degrees. So that should be what a 12-sided shape adds up to. Last one, we're going to look at another pattern. So it says we're going to start jogging 12 minutes a day. So our term 1 would be 12. And we're going to increase 6 minutes per day. So we'd have 12 plus 6 is 18, plus 6 is 24. We're going to keep going, and it's asking when would we get to 60. So term 1 is 12, our D is 6, and our term N is 60. So we're looking for N in this case. So let's plug all that in. So we'd have 60 equals 12 plus 6 times n minus 1. Now let's do the trick again. Instead of foiling it out, we can actually make it a little bit easier. So let's let's subtract the 12 first. So 60 minus 12 is 48. Divide by 6. 48 divided by 6 is 8. So we get 8 equals n minus 1. And let's add 1 to both sides. That gives us n of 9. And we're done. So that means 9 weeks would take us to get to the 60-minute mark. And that's all.